Hi friends, welcome to my class and good afternoon everyone. Today we can start our class with the famous quote. The most important work you will ever do will be within the walls of your own home. So this is a famous quote told by Harold B. Lee. Today we are going to see about number systems. First we can see the different types of number systems. So basically we would have been known about the decimal number system. So even in mathematics you would have been learning about decimal number system. Other than this we have the other number systems like binary number system, octal number system and hexadecimal number system. So all these number systems can be uniquely identified by their base value or radix. So in each number systems the count of the numbers of a digit in them is known as the base value or the radix. So this base value or radix is the general idea behind the positional numbering system. So these are the types of the number system. First one is decimal number system. Next one is binary number system. Third one is octal number system. And fourth one is hexadecimal number system. First is by decimal number system. In decimal number system, we have the values from 0 to 9. So 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. So totally here we have 10 numbers. So its base value or radix is 10. The next one is binary number system. Here we have the values 0 and 1. Only two values. So the base value or the radix is 2. Next is octal. Here we have the numbers from 0 to 7. Totally we have 8 values. So its base value is 8. Then next one is hexadecimal number system. In hexadecimal number system, we have the values from 0 to 9 and English alphabets A to F. So basically how we have alphabets, capital letter English alphabets from A to F. So totally here we have 16 values. So its base value is 16. So the other thing is how we have got this name hexadecimal is hexa is 6 and decimal is 10. So totally 6 numbers. 10 plus 6 is 16. So it is known as hexadecimal. Then now we can see about each type. So decimal number system. So here we have the numbers from 0 to 9 and it is the oldest and most popular number system. And here we use positional numbering system. So that means so each digit in the number is multiplied by 10 raised to a power corresponding to that digit's position. So now we can see this with an example. So now we have the number 0. Now we have the number 1, 2, 3. So 123 to the base 10. So whenever we are representing a number, we have to give the base. So in decimal number system, we have the base value or the radix as 10. So this 10 is given here. So now we have to give the positions. So we have to start it from right to left. So for the 3, the positional value, the power is 0. For 2, it is 1. And for 1 it is 2. So 0, 1, 2. So now how we have to calculate this? First we have to take the first digit 1 into 10. So 10 is the base value 10 and we have to give the power. So this power is the power of 1. So this 2, the power will be coming here. Then plus 2. So the next 2 is the next value 2 into 10 to the power 1. Then plus 3 into 10 to the power 0. So now we have to calculate it. So what is 10 square? 10 square is 100. So 100 into 1 is 100 plus 10 to the power 1 is 10 into 2 is 20. So 20 will come here. The next is 3 into 10 power 0. So 10 power 0 is 1. So 1 into 3 is 3. So the 3 will come here. So now we have to add all three numbers. So 100 plus 20 plus 3 is 123 to the base 10. So always we have to represent it with the base. So its base is 10. So this is from the decimal number system. We are calculating the decimal number system. So the same type. So we are getting the same value. The next type is binary number system. So in binary number system, we have the values 0 and 1. So totally we have two values. So its base is 2. So then its positional multiplier is 2 because the base value only we will be using here. And in this binary number system, we have the two forms. One is most significant bit and another one is least significant bit. So see, this is an example of a binary number system. So here we have only zeros and ones. So at the right corner, so that is the minimum value. So this minimum value will have, that is the smallest positional weight value. So this will be this value is known as least significant bit, and at the left corner, so this value will be having the largest positional value. So it is known as most significant bit. So now this is an example to convert the binary sequence into the decimal equivalent. So now this is the binary number 1101. So now we have to give the positional powers. So we have to start from the right. So here it is 0, 1, 2 and 3. So now how we have to calculate it is, first take the first number 1 into 2. So 2 is the base value, then we have to give the power. So the power is from here, the 3. Then plus 1 into, so 1 into 2 power 2 plus 0 into 2 power 1 plus 1 into 2 power 0. So that is equal to 8. So first we have to calculate this 2 power 3. So 2 power 3 is 2 into 2 into 2. So 2 into 2 is 4, 4 into 2 is 8. So 8 into 1 is 8 plus 1 into 2 square. 2 power 2 is 4. So 4 into 1 is 4. The next one is 0 into 2 power 1. So 0 into anything is 0. Then plus 1 into 2 power 0. So 2 power 0, anything to the power 0 is 1. So 1 into 1 is 1. So here we are getting this value 1. So now we have to add all those things. So 8 plus 4 is 12. 12 plus 1 is 13. So we are getting the value 13. So now this binary number is converted into the decimal number and we have to give the base value. So this is the decimal number system. So for the decimal number system, we have to give the base as 10. The next one is octal number system. In octal number system, we have the numbers from 0 to 7. So totally we have 8 digits. So its base value is 8. So while in the positional value, so we have to give the power of 8. So now see this example. So here 547. So now for giving the positional values, so for 7 the power is 0, then 1, 2. So now in the same method we have to do. So first 5 will be coming here, 5 into 8. So 8 is the base value and then we have to give the power. So this 2, this power will be coming here, 2. Then plus the next digit 4 into 8 power 1 plus 7 into 8 power 0. So now we have to calculate. So 5 is written as it is 5 into 8 power 2. So 8 square is 64 plus 4 into 8 power 1. 8 power 1 is 8. Then plus 7 into 8 power 0. So 8, anything to the power 0 is 1. So now we are multiplying it. So 5 into 64. So 5 into 64, you can also multiply it separately and see. So 5 4s are 20, 0, remainder 2, 6 5s are 30 plus 2 is 32. So total 320. So 5 into 64 is 320 plus 4 into 8. 4 into 8 is 32 plus 7 into 1 is 7. So now we have to add all three values. So 300 and so you can write it separately in the rough column and you can calculate it. 320 plus 32 then plus 7. So 7 plus 2 is 9, then 3 plus 2 is 5, then 3. So it is 359. Then after writing the value, so at the final step we have to write the base value. So now this is converted into the decimal number. So the decimal value, the base is 10. So the answer is 359 to the base 10. The next one is hexadecimal number system. So as I told already, So it has 16 values. So its base is 16. So this hexadecimal can also be known as hex numbers, and it has used as a shorthand for a binary sequence. So for binary sequence, we can also use this hexadecimal as the shorthand values. So this system is used to represent data in a more compact manner. Okay. So even in many other types in computers, we are using this hexadecimal number system only. Then here, since it has 16 symbols are used, so 0 to F, the notation is called hexadecimal. Okay, so as it is having 16 symbols only, it is known as hexadecimal. So as I told already, hexa is 6 and decimal is 10. So 6 plus 10 is 16. So that's why it is known as hexadecimal. So here the first 10 symbols is the decimal number values 0 to 9. The next 6 is the English alphabets A to F, A, B, C, D, E, F. So here the A will be taking the value. So A represents 10 and B represents 11, C is 12, D is 13, E is 14 and F is 15. So this is how the values are given in the hexadecimal number system. So now we can see an example to convert the hexadecimal into an decimal number system. So here also we have to use the positional method. So as we have seen already. So here from right to left we have to give the powers. So for 5 the power is 0, for 2 the power is 1. So its base is 16. So the power 6 is to the 16 power only we have to write. So first we have to take the first digit 2, then into the base value 16 and we have to give the power. So this 1 will be coming here 1. So 2 into 16 power 1, then plus 5 into 16 power 0. So now we have to calculate. So 16 power 1 is 16. So 16 into 2 is 32. Then plus 5 into 16 power 0. 16 power 0, anything to the power 0 is 1. Then 1 into 5 is 5. So 32 plus 5. So 32 plus 5 is 37. So while representing it as a decimal number, we have to write the base for the decimal number. So its base is 10. So 37 to the base 10.